Hi, good morning students. I am Vaishakhi Shah from LJ Institute of Engineering and Technology. In our subject Fluid Mechanics and Hydraulics, we already studied two functions, velocity potential function and stream function. Okay, and we already know the equations for velocity potential function and stream function. Velocity potential function is indicated as phi and stream function is indicated as psi. As we know that u, v and w are the components of velocity in x, y and z direction, and these are the equations velocity component function and these are the equations for stream function and velocity component function u, v, w and u and v in form of phi and psi. Here we have two equations for u and two equations for v. So, you can compare the equation. So, you get del phi by del x equals to del psi by del y and minus del phi by del y equals to del psi by del x. By using this comparison, you can solve so many examples. Okay. So, let us start the example here. First example is given to you. The velocity potential function is given by phi equals to 5 into x square minus y square. Calculate the velocity components at point 45. Here velocity potential function phi is given to you, where phi equals to 5 x square minus y square, and we have to find out velocity components at point 45. So, point given to you which is 4, 5. So, here x equals to 4 and y equals to 5. Now, as we know the equation for u, that u equals to minus del phi by del x. So, differentiating with respect to x, you get minus 5 into 2x, that is minus 10x. Now, here u is a velocity component and its unit is unit per second. Remember that unit is unit per second. Now, v equals to minus del phi by del y. Now, differentiating with respect to y, you get minus 5 into minus 2y, that is 10y unit per second. Now, at point 45, the velocity components where x equals to 4 and y equals to 5. So, u equals to minus 40 unit per second and v equals to 50 unit per second. Now, if in this example it is asked or don't ask, but you have to find out resultant velocity. It is compulsory to find out resultant velocity by after finding u and v. So, the equation for resultant velocity is capital V equals to under root u square plus v square. Now, we know the value of u and v. So, under root minus 40 square plus 50 square, which is 64.03 unit per second. This is the answer for resultant velocity. Okay. Now, next example, stream function is given by psi equals to 8xy. Calculate the velocity at point 45 and find velocity potential function. So, in this example, first of all, psi is given to you, which is 8xy, and the point given to u is 4, 5. So, x equals to 4 and y equals to 5. Here we have to find out velocity potential function phi by using equation of psi. Remember that here we have to find out phi by using of psi. How? So, let's start the example. First of all, as we know, del psi by del y equals to minus u. So, differentiating with respect to y, you get minus 8x. Del psi by del x, that is v. So, by differentiating with respect to x, you get 8y. Now, we have the value of x and y. So, place x equals to 4 and y equals to 5. So, you get u equals to minus 32 unit per second and v equals to 40 unit per second. After this, first step is to find out resultant velocity. So, capital V equals to under root u square plus v square, that is minus 32 square plus 40 square. So, your final answer for resultant velocity is 51.22 unit per second. Now, next part we have to find out velocity potential function phi. So, here for find out phi, we have to use the equation where del phi by del x can be written as del psi by del y. Here we are comparing the values of u, and minus del phi by del y equals to del psi by del x. We already studied this equation. Now, compare two values of u and two values of v. So, here first we can write down u equals to minus del phi by del x. Okay. So, u equals to minus del phi by del x, that is minus 8x, we have minus 8x value. So, you get u equals to minus del phi by del x equals to 8x. Now, del phi equals to 8x into del x, make del phi as your subject, that is 8x into del x. Okay. Now, integrating above equation, take integration of above equation. So, integration of del phi equals to integration of 8x del x, integration of 8x del x, integrating both sides. So, you get phi equals to 8x square by 2 plus f of y, where f of y is a constant, f of y is a constant for integration. Okay. And this is your equation number 1, where phi equals to 8x square by 2 plus f of y. Now, differentiating with respect to y, you get del phi by del y equals to f dash y, and we know v equals to minus del phi by del y, and the value is minus 8y, So, here f dash y you get minus 8y. Now, integrating that equation, you get fy equals to 8y square divided by 2 plus c, 8y square divided by 2 plus c. Now, place the value of fy in equation 1, So, your answer, final answer for phi is 4x square minus 4y square plus c. Okay. So, by using psi and by using relationship between phi and psi, you get phi by use of psi. So, in example, in data, either phi or psi is given to you, and by using this relationship equation, you can find out any other function. Okay. Now, our next theory is flow net. So, basically flow net are the lines obtained by drawing a series of streamlines and equipotential lines. So, flow net is a grid which is formed by number of streamlines and number of equipotentials line. Now, flow nets provide information regarding two-dimensional irrotational flow, where it is difficult to get that solution by mathematical equation. Okay. So, flow net is very easy method to determine type of flow, to find out seepage, okay, which we cannot find out by using mathematical equations. So, here as you can see this image, this is the image of flow net. Flow net is created below the earth level, below the dam section. There are two lines, first line flow line, another line is equipotential line. Okay. And there is one term which is field. So, where the flow line and equipotential line meets, that square box is called field. Okay. There are different methods of drawing flow nets: analytical method, graphical method, hydraulic model, and electrical analogy method. There are different applications of flow net also. by using flow net, you determine the upstream pressure on bottom of the dam. You can also determine the quantity of seepage below the hydraulic structure. It is useful to determine the design of outlet for their streamlining. It is very important for design any outlet section, and to determine the velocity and pressure distribution for a given boundary flow. So, these are the applications or uses of flow net. Now, there are some characteristics of flow net. So, the streamlines, there are two lines, streamlines and equipotential lines. So, both meets right angle to each other. Streamline and equipotential line must be right angle to each other. The field are square. The quantity of water flowing through each channel must be same. Through each field, the quantity of water which is flowing must be equal. The quantity of water must be equal, and the flow always takes in the direction of streamlines, not in the direction of equipotential line. The flow must be in a direction of streamline. Okay. So, this is the theory of flow net. Now, done for the today. Now, the remaining theories we will discuss in our next session. Okay. Goodbye.